Welcome to this presentation, and the presentation is on design of spate flow diversion and distribution structure. My name is Abebe Minch, and the contents of the presentation I have is: first I will give small highlights, introduction about spate irrigation in general, and it is traditional, modernized and newly introduced structures, and finally I will give some design criteria for the diversion of structures, intakes and canals. Flood actually is widely known for its destructive nature, but it have also advantage or beneficiary phases where it could be used as spate flood or spate irrigation or flood research farming, and also other benefits. And this is actually the destructive nature of it that we have in Ethiopia and radar, and this is where we have used it as supplementary irrigation in Borododota spate irrigation schemes. And spate is a focus, and also it's being introduced and also getting wider attentions in the world as well as in Ethiopia. For example, in Ethiopia it is getting introduced, in the midlands widely, but it's also getting focus in the lowlands where water is seen to be scarce. It have also future focus due to the climate change, population and pressure, and the increase in seasonality of the streams. And due to this, the focus is time to time increasing spate. And as it is defined, actually it is a science of diverting flood, this disaster flood, for beneficial applications. And usually we said spate, why not dam? And usually sediment could be one of the treats, and in those areas where spate is applicable, sediment is huge treat, and therefore usually diversion is recommended. And this diversion, where it is placed, need to be considered so that to understand the type of structure that we have put, which reach of the river, and for what purpose is an issue. And if we see the area where we could put the structures, we could have river basins like this, maybe divided into 3 ridges, and usually spate of the lowland is applicable or implemented in these parts where alluvial deposit is much. And if we see that the characteristics of the stream in the zones, we could see the discharge to increase when we go downstream as more of the tributaries are coming and joining the streams. And if we see the channel widths, it is smaller, or smaller widths the upstream, but when we go downstream it will be wider and wider. And the velocities, all the size of the bed materials are also going from boulders to more finer or alluvial deposits. Therefore, wherever we are going to divert the flood, or wherever we are going to place the structure, need to consider all these characteristics of the streams. Then, what are the characteristics of the flood? In general, we are talking about very flashy floods, or floods which last for short duration but in peak forms. And then when we talk about diversion, then we are going to use or make benefit of these flashy floods. And the floods are also not constantly appearing in the same time. They vary given the time when they appear in the year as well as the size year to year. Then how this resource could be diverted and how farmers have been diverting it traditionally are an issues to be considered while diverting the floods, because whatever lesson learned from the previous could be used for any future implementation or modernization. How traditionally it was diverted, this only highlights. Farmers have been diverting it only for part of it, not all of it, because they understood or they have learned from their repetitive experience that this destructive flood could endanger their fields, could wash out the diversion system as well, the intake and the canals and the fields. And also they divert from higher level where they could command more or less all the command area that they have. And usually two forms have been used, that is with some bundles and without bundles. And these are some of the practice which were made traditionally. And usually, or most of them, they have similar arrangements that the intakes are on the outside side of the bends, and they are easily could be maintained by farmers and designed by designed to be breached during the high floods, that is a safety factors. And if we see the canals which are conveying the diverted flood, they divert range of flood from 0 to the maximum, and also they follow the prevailing land slope. Usually the slopes are very high, and then sedimentation may not be an issue. And in space system, designers are not free to set the canal cross section and slope to carry the required discharge without also providing an appropriate high sediment transporting capacity. So this rules out the use of most conventional canal design procedures. And then high sediment transport capacity need to be given even if we are going to implement a new one as well. And if we look the traditional distribution structures, usually they are labor intensive and they are made from artisan or locally made materials. And this was all about, a bit of how traditionally water is diverted and distributed. And if we compare the conventional irrigation with the Spate irrigation systems on this diversion, distribution and conveyance system, usually the target of the diversion for conventional irrigation is on base flow, which is more or less predictable, and the Spate is on the peak flow, which is unpredictable. And the diversion and conveyance and distribution is more on the regulated and predefined flow, that is defined for time, discharge as well as the quantity. But in Spate those things are not there, but more or less the quantity, the total quantity which could be diverted are known. And if we see the canals, the flow in the canals, they can be approximated as uniform flow, but for the Spate they are non-uniform flows, as the discharge of the diversion is from more or less 0 to the peak flows. And when we see mode of flow control systems in the conventional irrigation, all that is upstream, downstream and proportional control works, but in the Spate system only upstream and proportional control works whenever the flow is available. And if we see operation of the flow controlling system, usually it maintains equity and planned schedule, that is all the schedule that is set, and also it is possible to maintain it in the conventional. But in Spate, there should be some established right and rules which helps us schedule, and also fair share or equity could be there if we are thinking about implementing new. And decision making procedures, if we see in the conventional, it is imposed semi-demand and demand, but in Spate it is mostly imposed. And if we compare the canal section, mostly in the conventional they are in service and they have more or less smaller cross sections compared with the size of the command area that they could irrigate. But in Spate, large cross section compared with the command area that they have to command. It is interesting actually to know, because for the sustainability of these systems, how and who operates the traditional flood control structures, and what is the means of communication for operating the traditional structures in space system, and what are the advantages and disadvantages of traditional structure in space systems. Understanding these concepts will help again for introducing new system where it is required. If we see the advantage, more or less these traditional schemes are flexible. The intake can easily be adjusted to suit the changing weir condition. They are low cost, high overall diversion efficiency, limit diversion of high flood and high sediment load, because they have breaching bundles. If the flood is huge, then the breaching band will be breached, and then it will maintain the safety of the whole systems. This is a bit of their advantage. From their disadvantage, enormous input of labor and resource to maintain and restrict intakes are required, and after the large flood destroys the upstream intake, the following flood can't be diverted until repair is made, and these are also the disadvantages. Then if we have these disadvantages and also advantageous things are there, but is improving the traditional diversion system required? If so, what consideration need to be taken? Improvement need to be done depending on site condition, available resource and farmers' preference, mainly with an objective of the labor intensive work have to be more or less reduced, and also reduce additional maintenance due to damage and siltation within the system, retaining the transnational diversion and management practice in line with establishing rule and rights, avoid an unintentional alteration of water division within watershed, that is upstream and downstream, cope with frequent and sometimes large changes in wadi beds. Having this objective, if it is improved, it was thought that to be nice, and then it was improved, and within the modernization some shortcomings were faced. Those are area in front of the weir, that is siltation was big issue, and gate operation often it was a problematic, no operator at the right time or gate getting stuck. Sedimentation ponds not operated and not maintained. Large investment in single offtake, often with long conveyance channel, creating conflict and deprive downstream water users. These are the shortcomings that was faced actually. And then while modernization, the lesson was, what lesson learned was, modernized system could sustain if the users or operators are consulted and participated in setting all the modernization options, that is from all the technical management operation. If all those things are discussed with the end user stakeholders, then their sustainability will be improved. And these points could be the way forward while modernization. learn rules and rights for water land of distribution. This will give the irrigation scheduling. At the beginning, we need to learn the established rules and rights on water acquisition and distribution from the area. Then the operational and scheme objectives need to be agreed and decided. Just while we modernize, we need to have an objective what to achieve. Is it protective or productive irrigation? And also the operational objective, we need to highlight it, how we need to share and distribute waters from where it is diverted in the wadi up to where it is used by the farmers. And also the financiers, designer, agency, all stakeholders need to agree on the system. So structures need to be operated and maintainable, and therefore the size of the command area need to be fixed at the beginning. Either we have to start from the previous command area where the size is already known, but accepting all risks, because the areas which have been under traditional Spate, sometimes they could be irrigated fully, but sometimes less and sometimes more. And there, our objective need to be in line with this. If we give hope for farmers, saying the objective is to give productive irrigation, but maintaining the extent or larger areas, and if the water and also the operation may not achieve that, there will be a gap between the farmers and the agencies, and therefore we need to fix the fields as well as the diversion, single or multiple intake need to be decided. All things, if they are decided by along with all stakeholders, designer, planners, financer also need to finance it, and also the end user, that is the farmers, then the sustainability of the modernized system will be improved. The last is introduction of new systems, and that is there are areas still where Spate is a potential and where farmers haven't yet introduced to it, and over these areas all things are starting from the scratch. There is no more or less established rights as far as water sharing is concerned, and also sometimes there are lands where Spate could be potential and which are not owned by any of the people, maybe for the government, and therefore introducing the Spate system not only for crop production but for different purposes, even to moderate climate, as well as to have rangelands in those areas. Introduction of this new system is required, and we need to have issues that we have to consider in these pointers. Actually, all the truths which we have learned from the Spate nature need to be incorporated at the beginning. Know the sediment issues, as there are high scoring effect, changing of river courses, strong user cooperation and commitment also as a requirement in the previous or in the traditional Spate system, and that the same thing will work in the newly introduced system as well, because humans are really resources in Spate system than even in the conventional systems. Hydrological information on wadi flows are in almost all cases very limited, and we need to understand this as well. And the timing, duration and maximum discharge of Spate flow are thus unpredictable, and accepting this, the interventions and the newly introduced system need to be designed. And also costs could be an issue, and it should also be need to be considered. Then the following are interlinked and important in developing new space system. Had it been traditionally in an area where traditionally Spate was practiced, there were more or less established right, and then the system might start by, the designing may start by accepting the established right and rules as scheduling and the structural design, and all flow controlling and communication arrangement could be aligned with the rights and rule which is already established. But in the Spate system, which is going to be introduced for the first time, then we don't have those all things. Therefore, there needs to be a closed loop where one should not tie the other, but things need to be changed till accepted system, structure, management and right need to be fulfilled. All these issues need to be done with a slogan which says design for operation, maintenance, management and always in participatory approach. Having this all, if we design the systems in our mind, having it needs to be operable, it needs to be maintainable, and it needs to be manageable, then more or less sustainability could come. Therefore, at the beginning, we need to define the scheme and operational objective, and as I have started, I said that it needs to be all issues, all discussion and decision need to be in participatory approach. Then first defining scheme and operational objective. In that way, the size of the command area and water distribution, that is the main and secondary, need to be decided. When we define the scheme, is it protective or productive irrigation or Spate irrigation? If we say productive irrigation, then we need to rely on the reliable floods, and then we need to limit the command area that have to be productively used, and the distribution also need to be in line with the people who are going to operate it. And then the right and rules need to be defined. Sometimes there might be right and rule, even if it's not for the water, but it could be in the committee for other purpose, and if that could be taken, that will be an issue, but more or less there need to be a right and rule which helps in the space system basically as a schedule to distribute the water. And then the flow control method, scheme management and operation and communication means need to be defined. The flow control method, if we define the right and rules, then the flow control method, the structures, and also the communication, how to operate the structures, need to be fixed accordingly. And then structure needs to be designed. So knowing the rights and rules, and then how to share waters, and then after knowing what kind of structure to put, whether with gate or without a gate, and then how to operate, how to communicate to distribute flood for the operators. After knowing all this, then the structure needs to be designed accordingly to fulfill all the above decisions. And then we need to check if the selected structure fulfills the objective and the water rights. Sometimes water needs to be distributed in some ways, but the structure are there to obliterate those rules. Therefore, we need to check all these, and if they are not going in line, then we need to come to the defining our operation and scheme objective, and then we have to make this loop, and more or less we have to define and design the structures at the end. So if we come to designing the structures, there are different variables that have to be looked into. The first is diversion, and the diversion, its location, levels, single or multiple, the type, body dimension and stability need to be designed. These are actually variables that are fine-tuned to have safe structures which will fulfill our objective, that is diversion and diverting the quantity of the flood which is required, as well as which will in line with the rights of water acquisition. And the intake also need to its alignment and capacity and its location also need to be defined. In conveyance canal, discharge cross section, longitudinal slope, and for the distribution, the method canal system, field to field, both are the variables that have to be decided beforehand. And if we use division box, then is it gated or splitted? That means without gated, need to be decided. So the variables at each section and level need to be fine-tuned to agree with the operational and scheme objective agreed by all stakeholders. So these are basically the variables need to be fine-tuned and decided by the designers to design the new systems. If we start from diversion structures, its height need to be decided. The height of the crust depends on the actual site condition and head required behind the weir enough to irrigate the critical point in the command area. Actually, having more, higher or a diversion which have larger or longer heights is good to divert more or less good quantity of floods, but is it cost effective is an issue, and could it resist the impact of the flood is also an issue. The other is whenever we raise the height of the heights, then the afflux which is rise in flood could bring over flooding in either side of the banks, and it may erode the fields. Then these issues need to be considered while fixing the height of the diversion and also the widths. And then the material of construction, whether it is masonry, earthen, band, gabion, wooden, concrete, still it need to be decided. Selection will be based on costs is an issue, availability, whether the material that we have selected is there or not is also an issue, and also its strength. Materials, sometimes, for example, if we use gabion, if our sediments or the sediments that we are talking are about boulders, sometimes with impacts, then we may have to maintain them more frequently. But it doesn't mean that we have to go to other portion, but more or less we have to select any of the material which suits the specific site conditions. And also it needs to consider accepted level of operation, maintenance and management. Well, if we do earthen bands, but if the farmers association or the agency which is going to maintain the structure is not there to maintain it whenever it is breached, then that will be a problem. Therefore, the accepted level of operation, maintenance and management have to be known so that to select even the material of the structure itself. And also knowing overflow diversion or breachable diversion is also an issue, because if we are designing the system to be breached, then we may not need to fully design with concrete or masonry structures. And therefore just these issues need to be considered to design the diversion structures. The other is the width. The wadi shouldn't be constricted, because scoring need to be considered whenever we are constrict the width of the wadi, so that to save the material of construction of the diversion, then the scoring depth is going to increase, and then it will undermine the strength of the structure. And more or less we need to accept at least the existing width of the river, and then we have to construct the diversion in that width. And there are also appurtenant structure or structures which support, which are along with the main structure, under sluice, for example, guide wall and flood protection. This need to be also be considered so that to make the structure more safe and to divert the required discharges. Under sluice, as much as possible, it needs to be along with the intake, so that to take or to remove out the sediments just in front of the intakes. And guide walls as well. Sometimes the geography is there where the bed level is more or less near to the surface, where there is no much left and right embankments, and during that, whenever we put any inch of diversion structures, there would be afflux where the flood will rise and may flow in either side of the rivers, the streams. Therefore, there needs to be some guide walls where there is this backwater curves upstream of the diversion to protect it not to flow to either side of the stream. And there are data actually which are required to design the structure. Hydrology. The hydrology, usually we should not focus on peak flow only for the safety of the structure, but also the dependable or the average flow that we could get and also command our fields. And sediment topography data, soil, existing agriculture and water management practices, if any. These all are also data which are really required to design the systems. So these are some of the type of diversion structures. It could be rockfill, and basically the diversion is either gravity or non-gravity. That is, the surface and subsurface flow over the structure is unavoidable. Therefore, to reduce or to resist the uplift force which is caused by subsurface flow, we may use either gravity weir, that is a weir which counterweights these effects through its weights, or non-gravity weir when the concrete slab floor is designed continuously with the weir body to keep the structure safe against uplift, and we may call this non-gravity weirs. And the design consideration for the diversion structures: best location to be determined by comparing the wadi level, field level, with allowance for rising and canal slopes, and managing for big floods. Gravel or soil embankments will bridge to enable passing of big flood, and in this way we can manage the big flood as well. And if we have to put also sluiceways or sluice structure which helps to under sluice structures or sluiceways, then it needs to be at upstream part of the wadi where more water is available for flushing. Diversion height should be limited with the allowable afflux, that is the rising flood. The intake gets to only be provided if required by farmers. That is, it should be in negotiation with the farmers. Sometimes farmers may not need gate as well, and they may need to manage the excess flood in other options that they have. For example, it could be side spillover or escapes, which enables rejection of excess flows. And the intake structures need to occupy less than 20% of the wadi width and should not allow large devastating flood. And therefore, head regulator limits the maximum flow into the canal, and head regulator could be used as an option to limit or to regulate the flow of water through intakes. And sometimes if the head regulator is not there, then free intake could be provided, and downstream of the free intake side spillway or escape should be provided, so that if the bigger flood is diverted or entered through intake, then it have to return to the main streams through these escapes. And intake alignment should be optimized, the sediment that can be diverted along with the flood. If we use intakes, for example, these are the intakes that is provided. This is the diversion that is upstream to downstream, and this is actually the intake which is now filled with sediments. And this is actually structure at Abebe in the west of Hydrology in Ethiopia. And the alignment, if we see, this intake is in parallel with the diversion structures. And if the intake is in parallel with the diversion structure, it means that larger floods could be diverted, because there will not be any resistance for flow to enter to the intakes, but along with the floods, but the sediment will also enter, and sooner it will be sedimented and filled. And the other option will be to align the intakes in some angle with the diversion structures, and just that alignment need to be actually fixed based on the site condition, the amount of sediment in the area, and sometimes also it might not be possible to divert it in the alignment that we need, because the geological and geographical makeup of the site where diversion is made could also limit us. And anyway, this diversion angle needs to be fixed, because whenever we are making, for example, 90 degree, we are diverting less water and similarly less sediments. That means sediment might not be a threat, but we are reducing the amount of water which is diverted. And if we make it parallel, then large flood could be diverted along with large sediments, and sediment will be threat. Therefore, it needs to be balanced, the angle of the alignment of the intake. The design consideration for canal capacity. Water conveyance and distribution system developed for pioneer irrigation are not appropriate for Spate system as well, because the sediment concentration and other issues, even the flows, it is uniform in the conventional but not in the Spate. All this issue makes the water conveyance and distribution system developed for pioneer not too suitable for the Spate system. Then need to convey a large volume of water by gravity to fields during the short period when wadi flow occurs. This is typical Spate systems. And then the design discharge in some way need to be anyway fixed. If we design the section of the canal for the maximum flood that we are diverting, then we are over designing the structure, because this maximum flood is going to happen only for short minutes, maybe for an hour. Therefore, the rule of thumb says let us fix the design discharge to be 70% of the maximum discharge, and after designing the cross-section for that, then we need to add the freeboard to accommodate the maximum discharges. And mulcher capacity are needed actually to pass 10 to 100 times greater than for pioneer system. Therefore, we need to design the system not for the maximum, but for 70% of the maximum plus the freeboard to accommodate the maximum. Flow velocity will be higher than the conventional canal, and we need to consider this as well. But if we try to give the slope which is almost similar for the conventional, then the canal will be sedimented and it will stop its functionality. Therefore, higher slope needs to be given, because higher sediment loads are also diverted with the flood, and then the sediment holding capacity or carrying capacity need to be given from the canal itself. And the other is designing consideration for distribution of floods, and this distribution could be either field to the fields, which is actually implemented in other parts of the country, like in other parts in Pakistan, and also in Sudan, and also Ethiopia. And also there could be an option for using distribution canal systems, if not like typical conventional, but at least to use more canals to distribute the water to the command areas. That's all I have for this, and thank you.